Hello, my name is Vamshi Krishna. Today we are going to read about CAD-CAM design in Nurbs. Nurbs, N-U-R-B-S, stands for Non-Uniform Rational B-Spline. Today we are going to study about this. Now here, coming to the form of nerves, we can see that nerves are mathematical representation used to create and represent curves and surfaces in computer graphics and CAD. They can model complex 2D and 3D shape, including freeform surfaces like car bodies, aircraft wings, and architectural structures. Components like control points influence shape of the curves or the surface without necessarily lying on it. Knots define the parameter spaces and influence the curve's behavior. Weights allow them to curve to the surface influence near the control area. Degree. It determines the curve smoothness and flexibility. Widely used in the industrial such as automotive design, aerospace, shipbuilding, and animation for the creating precise and the smooth geometrical and like polygons. Nurbs provide continuous curves and surfaces without switching, making an ideal for the high precision design. Nurbs using B-spline curve equation. The derivation of the rational spline curve are obtained from the different equations. So P dash of t equal to summation of I equal to 1 to n plus 1 BIRI power n into k into t. So by solving the following equation and evaluating the results at t equal to 0 and t equal to n minus k plus 2 yields p dash of 0 equal to k minus 1 of h1 upon h2 of b2 minus b1, which shows that the direction of the smooth along the first and the last polygon spans respectively. Higher order derivatives are obtained in a similar manner. So by seeing the following equation of p dash of 0 equal to p dash of n minus k plus 2 equal to k minus 1 of hn by hn plus 1 and b of n plus 1 minus bn. So here given the following equation, we can solve the curve equation using the B-spline. So r dash of 1 comma k of t equal to h I n I dash of k of t by summation of I equal to 1 to n plus 1 of h I n I comma k equal minus. So implementation in the Matlab. P of t equal to h1 of n1 comma 3 t of b1 plus h2 of n2 comma 2 of t of b2 plus h3 of n3 comma 3 of t of b3 by h1 of n1 comma 3 t plus h2 of n2 comma 3 of t plus a2 of n2 comma 3 of t, which in fact a third order equation of Weiser curve. It is the correct moment and assumption h1 equal to h2 equal to 1. The equation of 5 to 1, then we reduce p of t equal to n of 1 comma 3 of t of b1 plus h2. Now if h2 equal to 0, a straight line between b1 and b2 results. If h2 is infinity, the definition polygon is reproduced when h2 equal to 0 and t equal to 1 by 2. The midpoint of the b1 and b2 labeled in the m at t equal to 1 by 2 on the curve. P of t moves along the straight line connecting m1 and b2. S is called the shoulder point. The value of h2 determine the type of conic section. h2 equal to 0 is a straight line, 0 less than h2 less than 1. An elliptical curve segment results. h2 equal to 1, a parabolic curve segment results. h2 is greater than a parabolic curve results this curve. Using the equation p of t equal to 1 minus t square of b1 plus 2h2 t1 into 1 minus t into b2 plus t square b2 by 1 minus t. Now here the circular are using the Nurbs. So given here a triangle inserted by a circle and a square which is inside a circle. So the rational basis for the 120 degrees segment is the triangle one, and the 490 degrees angle matrix is the in showing in the figures. The bounds of knot and the segment is similarly the full circle is also given by the 4 rational quadrant B-spline curves recognized by the summation. Here x equal to 0 comma 0 0 0 double 1 1 2 2 3 3 4 4 4. Second matrix is equal to 1 root 2 by 2 is to root 2 by 2 is to root 2 by 2 is 1 to root 2 by 2 1. An example of standards and technical for generating the conic section ring rational base curve. Now here graph is represented as a small part of a triangle inscribed in a parabolic type of structures. So here the conic section is repeated is called as B-spline curve. So for t equal to 1 by 2, p of 1 equal to s, which yields s equal to 1 by 1 plus h2 into b1 plus b2 by 2 plus h2 by 1 plus h2 into b2. Now here the code execution which we need to run in the Matlab. So by the following is equal to input, enter the is equal to con. So by all these coding we need to connect it in the Matlab, and the following we need to run in the Matlab to represent, and we need to plot the points by which a triangle inscribed in a circle, so a circle which is inscribed in triangle and a circle which is inscribed in a square forms by the form of this code which we need to run in the Matlab software. So following we need to open the Matlab and we need to solve the curve. So we need to set the input control point. So now in the shape of a triangle with 6 points we need to plot the points. So we need to join all the points with a freehand curve-like structure, and then we need to enter the number of control points we have entered as 7. Enter the weight for the control point 1 equal to 1. Enter the weight for the control point 2 equal to 0. Now and for the point 3, and for the point 3 is 1, and for the point 4 is 0.5, and for point 5 is 1, but point 6 is 0.5, for point 7 is 7. So now enter the weight. So by this, so we will form a parabolic type of curve which is formed from the given points. So this was my presentation regarding the Nurbs. Thanks for watching the video and hope you like my presentation. Thank you.